Okay, to start, go to this link. I'll put this in the video description. Download it. It's a normal zip file. Save it wherever you want and unpack it wherever it's convenient for you to get to. You'll need to have Python installed in the folder where you have this zip file unpacked. And that's it. That's the entire installation. Just unpack it, and everything you need is there in that pyDAL-JSLim folder. You'll see there are a number of tutorial examples, which we're going to go through now. The first example is the most minimal bottle example. We're going to do just the back end system first. And you can see that in Python here, this is a normal Python file. We're going to, from the bottle library, import the root and run modules. And you can see on the hard drive, basically, you don't have to do any pip install. Just in this unzipped folder, we have the bottle.py file. That's the entire bottle library. There are no other dependencies aside from just the standard Python library. That's all you need. And also, you're going to see there's a folder here, pyDAL, which also is the entire pyDAL library. And again, its only other requirements are the standard Python library. So this entire system is ready to go. And while we're at it, you can see there's a UI library, which is the entire JSLim library. So we've got some more tutorial examples to do there. So again, go back to the main bottle.pydal and JSLim folder that you've unzipped. Scroll down to your bottle tutorial 1.py file. And so we've imported from that bottle library root and run modules. And the first thing you're going to do in a bottle file is create a root, decorate it with the @ symbol, and you choose the path that you want the next function to be run from. So whenever a user goes to the default path, so if we're running this on localhost, or if we're running it at an IP address, they go to that localhost in their browser, or they go to that IP address or that URL in their browser, and which if they're at the default path, it's going to run whatever function comes next. So I have a function here that we've called hello. And all that function does is return some text that says hello world. So that return value will be sent to the browser or to whichever other application sent the request to the URL where the app is running. So the next line, you'll see the run function that has some parameters. You can set up your host IP address. By default, you leave it at 0.0.0.0, which makes it accessible from other machines. You can set this, for example, to run just on localhost if you don't want people to be able to access the application from another machine. But typically, these are web-based apps, so you want them to be accessible on any client that can connect to it. Here I have the port set to 80, which is the default port for web applications. So typically, when you're running on port 80 in a browser, you don't need to put :80, port 80, just put the URL address localhost. If you change this, then instead of just going to localhost, you'd go to localhost : whatever port number to run the application. The debug equals true parameter. Basically, that gives you more detailed output in the console, so you can see what sort of transactions are occurring and what it's sending back, any errors. You don't want to run this in your production application. It'll slow it down. And also, same is true, the reloader equals true parameter. What the reloader does is anytime you make a change to the application, Bottle automatically restarts the server with the new code. So it keeps track of anytime you make changes to the code. So it makes it really quick and easy to edit and run your applications live. Okay, so to run this, we go to the folder. You're gonna have to CD to whatever folder. I think we've got this here in the download folder. And then it's in whatever folder was the name was unpacked to. And so you can see all those same files. You'll notice in this folder that there is a start server.batch file and a start server.sh file, but all they do, they have one line in each of these. It's for Windows, it's Python and then server .py. So it'll run this demo server app. We'll get to that later. And the sh is for Linux. Start server.sh is again just one line, Python 3 space, and then server.py. So we don't need that here. We're at the command line. We're going to run those commands manually. So let's go ahead and do that. Run Python, and we'll do the bottle tutorial number 1. You can see it's very quick to run. Now it's listening on port 80, and you just press Control-C to end it. You can start it again. It's just quick. Okay, and now we're going to go to the browser to run that application in the browser. Let's again go to the browser, and for this particular application, we're going to localhost. So that, and you can see it's returned to the browser the string hello world. If we go back to this application, let's edit the code a little bit and change that to say, for example, hello bottle world. And the server will rerun at the command line, and we can go back into our browser. If we refresh the application now, it says hello bottle world. Okay, so that's the most minimal bottle application. Let's get our next little example here. We'll go back to the command line, stop that application from running with the Control-C, and let's run bottle tutorial 2. And you can see it runs really quickly. Go back to our file system. Let's edit, look at bottle tutorial 2. Okay, so it's almost the same code. We've got one little addition here in the hello function. We're setting a variable called name to whatever is stored in the request.query.name variable. And then we're taking that name variable and sending back this concatenated bit of text which says hello, and then we're formatting whatever that name was with an exclamation point. Everything else is the same. So the way we run this, the query is whatever is sent to that URL by the client. So in this case, we can do this right in the browser by typing question mark and then setting name equals some name. So we run that, and then you see it says hello John. If we don't have a question mark, we're just going to get hello and nothing, because there is no name in the query string. Change that string, you can see it'll change the name so it reflects whatever was sent in the query string. If you're not familiar with query strings like these, there's just typical get requests. You can read up on that elsewhere. It's a little bit out of the scope of this tutorial, but basically you put a question mark after the URL where the application and the route is running, path that you have for that function, and you set a variable to be some text, and it's a URL encoded text, so spaces get a percent sign 20 and so on. You can read up on that on Wikipedia if it's not familiar. So right now we're just going to do these server functions, and later on we're going to tie it all into the front end. Next example is this bottle tutorial 3. Let's go back to the command line, stop bottle number 2, and normally we'd be working on just one file, so there wouldn't be all this starting and stopping. It's just because we're running a different example every single time. Normally that server just restarts every time you make a change and save the file. So workflow is very simple. Now we're running this third application. Let's go back to our code and see what it does. Okay, so in this one, you can see now we're importing not just the root and the run modules, but also the static file module. What that does is it lets Bottle serve to the client a file that they specify. So again, the first thing you're always going to see in each of these Bottle functions is a root. And again, we have this set to the base path, so just localhost, since we're running out in localhost. And you're going to see a function. And whenever the user goes to this particular route in the browser, it runs this particular function that follows that route. And this function, all it does is return a static file, and the parameters are the name of the file and the folder, the root folder that file is contained in. Everything else is the same. So now if we run this, you can see we've set an index HTML file to be the file that is this index page right here. If I open it up just in my folder here, you're going to get this list of file names. So let's go back to localhost, and you can see that Bottle has delivered this file back to the browser when we refresh. There you go. So there's the index.html file being sent back to the host, or being sent back to the client when you go to that localhost address. Okay, so next up, let's stop this and run tutorial number 4. All right, just really quick to get started, very lightweight. And we will open in our editor. Any text editor will do. You can use an IDE. I'm using Notepad++ here. It does some nice syntax highlighting, but any IDE or lightweight text editor will work to edit these Bottle files. Okay, so you can see here now we've added a couple more modules. We have the static file, root run, and also the request module. So now we have 2 functions. There's a route at the base path. So this is localhost or whatever the IP address, wherever this server is running. So other clients can come to it from other IP addresses. Connect to that IP address or connect to localhost if you're running on the same machine. And let's keep this tab the same. And so the route function is what we just saw. The route base path here is the same as we just saw. If you go to localhost, you're going to get the index.html file in this root folder. And then we have this hello function, like you saw before, at the route. So if we go to localhost/hello, it will run this hello function. Function can be called something different, doesn't matter. You can see up here, the name of the function is whatever you want it to be, and the route is whatever you want it to be, just a path attached to localhost. And this function, similar to what you saw before, we're creating a name variable, set it to whatever is in the query that gets sent. So you've seen we're sending those GET requests. So in that request, whatever follows the question mark and that query and the name variable that's set in that query is retrieved, and we're assigning it the variable name. And then we're creating an output variable, and inside that output variable, we're going to find the so a little bit of HTML code here, H1 tags surrounding the word hello, and then the formatted name that we've gotten from the request query, and then we're returning that back to the browser. So we're going to get a bigger hello here with a name. So the big point here is that we have 2 separate routes. If you go in the browser to localhost, you run this function. If you go to localhost/hello, you get the output of this function, the hello function. So let's go ahead and do that. Switch back to our browser and run localhost. Ta-da, we get the index file. And then if we go to localhost/hello, there we go, big hello. Now we haven't put any sort of request parameters, so I'm going to do a question mark. Let's do Joe. If we change that to another name, that's what gets returned by the hello function. Okay, so now we have several different routes running. Let's go ahead and stop this application. And we'll run example number 5. And let's see here, we'll go back to our folder and we'll open up example tutorial 5. And so you can see it's all the same code that we just had with a little bit more added. This time we're importing the OS library, and we're creating a root directory with this Python code. And all this does is pass back the current working folder. So wherever this application is running, we're getting the full path to it. We still have this route running at the local host, where it's going to deliver the index.html file. And we still have this hello function that you just saw, where it's going to say hello to whatever name is passed in the query. And then we have a new route, and this is at the base address. And you can see this is the syntax we use to refer to a file name. And what's going to happen is it's a variable file name that can be passed in the request. We have a function which we've called serve static, pass it the file name that is passed into the request. And what's going to be passed back to the user is that file, pass back a static file from that root dir, root directory. So let's go ahead and do that. Let's, in our browser, again, if we run the hello function, we get this. If we get the base address localhost, we're going to get the index.html file. And then if we give it a file name, let's send it that start server.bat file. We can see the contents of the start server.bat file. If we were to pass it some other file that needed to be downloaded, like a binary file, that would be downloaded to the browser. Okay, so now we have those three functions already running. That's really useful because we can pass any files we need back and refer to them specifically by just letting the user type in the path of the file. So we could have, for example, a number of index, HTML files and various other files that will just open if you open the name of that file in BOTL. So it's acting like a little web server using that function. Let's run up the next tutorial example. Tiny keyboard here. Let's see what we got here. Oops, type pi. Okay, go back to our BOTL tutorial 6.py file, and let's see how that looks. Okay, so again, everything is the same in this bit of code, except now you can see we're importing the standard JSON library from the standard Python library. It's the JSON library. We previously imported OS, and from BOTL, we're still importing all those same modules. All this code is the same. We've got the case route here. We've got a file name path route. We've got a hello route, and now we've added a route for JSON. So if the user goes to localhost /JSON, we'll run this function, and we'll return the data in this that's processed in this function back to the user's web browser. And so in this function, what we're doing is setting a variable called data to a list which contains two dictionaries. The first dictionary, we have a name key set to the value Bob, name 1 key set to Bob, a note 1 key set to the string Bob likes dogs. And then same sort of thing for this next dictionary. Name 2 is Joe, and note 2 is Joe likes cats. And the reason we imported the JSON library is so we can use the JSON.dumps function or method to send back that data variable to the browser, so it formats appropriately and make sure that the data is sent in JSON format. So if we go back and run this in our browser, again, we have all the same paths. We can go back to localhost and get our index.html file and so on. If we go to JSON, we're going to get the JSON returned from that return JSON function. So this is really important because most front ends will connect with the back end and transfer JSON data back and forth. This is the most common method of getting data returned from the server, and Python handles it beautifully using that JSON library. So that little example is super important. We'll use it a lot with the front end tooling that we're doing later on. Okay, so let's go back, get tutorial number 7. Now, tutorial number 7, we're going to take a little break from BOTL for a bit. We'll stop this BOTL server and run tutorial number 7. Now, what you're going to see here is just a whole bunch of data printed out at the command line. Okay, so we've got a bunch of data there. It's showing us what's in the database. Let's take a look at this example. So this example is our first pyDAL example, and this demonstrates how to perform all the basic CRUD operations using the pyDAL library. So you can see we're no longer using any BOTL code for the moment. We're going to go back to that in a minute. From the pyDAL library, we're importing the DAL module and the field module. And the way this works, this is a Python ORM, or a database abstraction layer, that lets us connect to any of all the most common database systems and use a single Python language, so we don't have to use SQL. Everything stays pure Python, and we can connect and migrate to any other database system just by changing this little query string here, and it supports all the most common databases. By default, out of the box, it runs SQLite, which is installed with all the versions of Python 3 and Python 2.7, I think all the way back to Python 2.5 or somewhere around there. By default, if you have Python installed, you've got SQLite installed. But you can change that to MySQL, change it to Postgres or MS SQL, or even some of the NoSQL databases like Mongo and Google Data Store. All you have to do is change this. Change this connection string. All the other code stays the same. So the way this works, the DAL library is very nice because it's been used in production for a lot of years, very stable, and it doesn't require any other modules. Again, we just have this installed in a folder right here. Nothing else to install. If you have that folder, it's fully installed. You can install it. You can import the library. You can also do a pip install if you want. Same with the bottle library, pip install it, but not necessary. Okay, so to use pyDAL, first thing we're going to do is create a variable that represents the database file in SQLite, or the database connection using one of the other server-based databases. And we use that DAL function to make the connection. In this case, we're connecting to a SQLite database, and we're going to store it in this file name, tutorial7.db. We're in tutorial 7 now. So that creates the database file, makes a connection to it, or if you're using another database system, it connects to that database system. Usually involves a URL and a password and that sort of thing. Then with this database defined, we can define a table, and that's just db.define_table, and we give it a name, the table. Here we're creating a table called people, and we're going to create two fields, first of which is a name field, and we're going to say that name field needs to be unique. There are a lot of other options for these properties. You can set up value types and so on. But for our purposes here, we're just going to make this first field unique, and then another field called note. So these are columns in the database table people. We have a name and a note column in the people table within this tutorial.7 database file. That's it. Do a db.commit, and it is saved. You now have a database running. Now, the way we work with that database, you can insert rows. So this is the create part of CRUD. To insert a row of values into the database, we use this db.people.insert, pretty obvious. And we're going to set the return value of that to the variable row so that we can see if it was created properly and get the ID and that sort of thing from the return value from the database. So all we do to create to insert a row is do the name of the database, name of the table, and then the operation is insert, db.people.insert, and then we set the name column to be Joe, and then the note column to contain the text Joe likes dogs. Do a db commit, and it's done. And here at the end, I've just printed out the row ID for that newly created, the newly created row, that newly inserted row. Okay, to do the read portion of CRUD, we've done a create, now we're doing a read. What we do is do a db.select, and this little statement here is we want dbpeople.all. That's the search that we want to perform, the select that we want to perform. And again, we're going to set the return value of that search, that select, to the variable rows, and then print that row. So this will give us all of the rows of the database. Straightforward, just learn that syntax, and we'll adjust it later to do different sorts of searches. Okay, now to update a row in a database, same sort of thing. We're setting a variable. What's going to be returned by default from this next is a count, the number of rows that are updated. And the way that you perform the update is db, and then in the database called db, in the table called people, we're going to look for where the name, or in any of those rows where the name equals Joe, and then we're going to perform an update statement, and that in that update statement, we're going to change wherever the name is equal Joe, we're going to change the name to Joe Smith, and we're going to change the, oops, not date. It should say actually note. Go. Good. So that, and it'll give us a number of rows that was done with that transaction. Now remember, we define this table so that the people table can only have a unique name in each row. So if we try to create 2 rows with the name Joe in the name field, it'll send back an error because it'll tell you that that unique property has been violated. So in any of these occurrences where we're doing an update, you're only ever going to get a row count of 1 because we've kept that name column unique. Okay, and then just to see how to do this sort of thing a little bit more, you can use a Python for loop, read and loop through each row of the database values. So here we're getting, we're doing a select in which all of the rows of the people table are returned, setting that set of values back to the rows variable. And then we're going to use a for loop to go through each of those rows. So for row in rows, we're going to print the row name column, the row note column, and the row ID. The ID is created automatically in SQLite, so that there is a unique ID for every single row. Even if other values are the same, you can always use that ID, and you don't have to do anything. pyDAL and SQLite do that for you and handle that automatically. So this just loops through each of the rows in the database, prints out the name, the note, and the ID of each row. And then finally, to do a delete, similar kind of format, we're setting the result of this to the row ID variable, and to perform the operation, to perform the delete operation, we use the DB, and we're referring to what we want to do here is take in the DB in this database in the people table, wherever name is equal to Joe Smith, we're going to perform a delete operation and then commit the database. And then here we've got this same bit of code that you've seen already. We're going to print out that all of the rows so that you can see that that change has been deleted. So that's it. These are the most important functions using pyDAL. Very, very simple. You don't need to do any installation. SQLite's already installed with the system. Again, all you need to run this entire system, front end and back end, is just Python 3 and an editor and a browser. And you can use Python 2 also. Everything works out of the box without doing any install. Just use this code, memorize these little bits of code, and you can use pyDAL to do all the basic CRUD operations. And we'll cover some more as we get looking at other examples. So let's run that example one more time. This is the example we just saw, model tutorial, and you can see it's returning when the initial create operation is run, it gives us the ID, and then here we're printing out the entire database, and then we get a count for the number of things we've updated, and then we've got another nice little printout where we loop through and print the name, the note, and the ID of each row. And then again, we do a delete, and you can see that the Joe rows have been deleted, whereas here in this previous print, they were still there. So that's the full set of fundamental CRUD operations you need to make pyDAL work to interact with databases. Now, what we're going to do is integrate those two things. We're going to integrate pyDAL into pyDAL. So each of those functions that run just at the command line now are going to run whenever a user goes to one of the routes that we have set up. So let's look at tutorial 8, and you'll see what we've got here is all the same pyDAL code that you saw previously in each of the examples 1 through 6. But we also have all of the code you just saw in example 7 integrated into new pyDAL routes. So we still have from pyDAL import the root and request and static file and run. We're still importing OS and the JSON library, standard library from the Python standard library. And from the pyDAL library, we're importing those DAL and field modules. This is all the exact same code that you've seen, the bottle code. We create a root directory in our current directory. Here we've got the initialization of the database. Now, the way this works is the first time you run this code, if the database doesn't exist, it creates it. If it's already created, and if the table is already created, those things are just left as they are. If you make any changes to the table definition later on, it will change the database to match those new table definitions. So if this is already existing in a database, if that file exists, if you create another file here, for example, it'll create a new file. Change the file name, it'll create that file name and create that entire table definition. If we were to add more fields here, it would just add those fields to the table in that database. Okay, and we still have our initial roots that we had previously, where we're returning the index file, we're returning a file that's selected by the user, our little hello function, and the JSON function. Now here, everything after that is create, read, update, and delete roots. And within those roots, we're running some functions that do exactly what we just did in the tutorial 7. So we've created a new root. When the user goes to localhost or whatever the IP address is, localhost /create, we're going to run this function, which we've here called create crud. And we're running the db.people.insert operation that you've seen. And we're going to set the name column to be whatever is sent by the user in the request.query.name variable, and the note column in the database, in this new row of the database, to whatever is sent in the note value of the query. Commit the database and then return back to the user a little bit of JSON that shows us the ID which was added to the database. So this is the way the URL is going to look. We're going to go to localhost, and then we're going to run the create route, which is this route. We put that in the path, and then send some values. So question mark name equals John, no equals John likes cows, and those %20s are just spaces in URL encoding. So let's do that. Maybe we'll change it up a little bit. Go to our browser, and let's first make sure we're running server. So this server application is called Bottle Tutorial 8. Now that's run. Back to our browser, and let's copy, paste that URL in. And we may get an error here if there's already a name John in the database. Let's see, because the unique, nope, there wasn't. There we go. If we try and run that again, you can see it's returned an ID. This is a row with ID 25. That's a unique ID. If I run this again, you're going to see we get an error, because you can see here the exception, unique constraint failed on people.name. We have that unique constraint put in, and we can handle that however we want in our bottle code. But just so you see that it is, pyDAL is enforcing that unique constraint. We could create another name here. Let's say, call this Mary, and we'll say, and this, Mary likes cars. Okay, now we've got a row with ID 26 added to the database. So you can see the create operation is working as expected. Let's go back in our code. Here's our root for create. Now we go back down to this root for read. So now if the user goes to localhost read on this machine, it will run this function in the bottle server. And we're going to run this same select that you saw in the previous example. We're going to set the rows variable to be all the rows that are returned from the database. And then we're going to create this new data variable, which is a list structure. We're going to go through all the rows in the database and append to that data list this dictionary, which contains the name, key, and the name in that row, and then the note key, and in that row, the ID key, and the ID of that row goes through each of the rows and builds a list of these dictionaries. a very, very typical thing to do in any sort of Python or any sort of other programming. A list of dictionaries created by looping through the result of a database call. And then we're using json.dumps to return that data, that JSON data, back to the user. So let's go to our browser and we'll go to localhost/read. And blammo, that's the entire contents of the database currently. So obviously very useful when we get to using the front end system, any front end system, which can send a request and then receive the returned JSON code. You're going to be able to use that JSON in your applications to show, for example, in a UI widget. Okay, so let's go back here. Look at the next little path we've created here. The next route is delete. So we're going to go to the localhost/delete and pass it, in our case, a name. So when we do that, Bottle will run this function called delete crud. And what we're going to do here is run this same pyDAL code that you saw. We're going to the people database, the DB database, the people table, and wherever a name equals the name that was sent in the query that was requested by the client. And we're going to delete that, perform the delete operation just as you saw. It's the exact same code you saw in tutorial 7. Commit the database and then return the ID of the row that was deleted. So let's go ahead and do that. Let's just open that one. Okay, we can see here there was no Joe in the database. So let's, for example, try John. There we go. So the ID now has been returned. I think that's actually the result count. Let's try deleting Mary, the Mary row. And there we go. If we try and delete some other thing, some other row, some other name that's not in there, we get 0. Okay, so the delete is working as needed. And again, we can just access this by a URI, a URL. This is a REST API. Any front end that can work with this sort of sending a HTTP request and doing something with the return results can use this backend system. So finally here, we've got an update function, create a route where the path is, in our case, localhost/update or whatever IP address our server machine is running on. Browser goes to that URL. And you can see in our case, what we're going to do here is pass a name variable, in this case, in this example, John, and then a new name value. Here we've got John Jones passed, and then a new note. In this case, we got John loves cows as the new note. So when we go to this, this is just a little, be clear, this is just a comment. That's not part of the code. So when we go to this route /update, it's going to run this update CRUD function. And we're going to do what you saw in the previous example to update a record. And what this code does is it looks in the database, in the people table, and anywhere where the name column is equal to the name sent in the query, the name variable. So up here, if the query is sent with a matching name in any of those rows, it's going to update that row so that the name column is equal to the new name sent in the request, and the note column value is equal to the new note value sent in the query. So up here, would any column with name equal John will be sent to, or be reset so that the name is then new name value and the note is the new note value. Commit the database, return the count of rows back to the client. So let's do that. In fact, let's just click on this. I don't know that we've got a row anymore with John in it, but let's put that in. Okay, so count 0. So let's go back a little bit here and we'll go back in our in our, here we go, let's create a John entry. This is a previous example. Create John. Okay, so you can see we've got an ID of 27 on that. Now, if we run this update again, where John is updated. Okay, it looks like we've tried to do this on two different, two of the same rows. So I think you can see the system is working as it needs. I just need to do this with another name. Let's say we'll change the nickname to be here and here to get a proper GET request. New name, we'll just change that to Nick Smith. And then we'll change the and the new note equals Nick loves cows. There we go. Ta-da. Okay. So that is all of our CRUD operations running in the bottle framework and using the pyDAL library to interact with our database. And again, we can change that database as long as you've got the driver installed for whatever database you want to use. MySQL, Postgres, any of those other databases, a huge list of databases this works with. You just have to have that driver. You pip install the driver or download the driver and install it manually in the same folder. And you can use any other database without changing any of this code. So one of the great benefits of using an ORM library or a database abstraction library like pyDAL is that you get to use any sort of database system you want, and all of this works with pure Python code. You don't need to change your mental model and switch back to SQL. And it's of course a little bit simpler to work with, and so migrations are easier as the applications get bigger. This makes a huge difference. But of course, you can do all these same things within Bottle without having to use pyDAL. It's just a great convenience, and as the applications get bigger, it makes the code much more readable, and it's a lot more pleasant to work with the database ORM. Okay, so that is it for our backend introduction. I'm going to end the video there. And the next video, what we'll do is take a look at the very first front end framework, which is JSLim. JSLim has a beautiful visual drag and drop designer, an IDE that runs in the browser. It's all installed in this download. This is a download of about 2.5 megs. And all these application examples are in there. We're going to go through how to do all of the front end work using JSLim. And in future tutorials, I'll cover some of the other possible front end frameworks. You can swap out that JSLim framework for any other front end framework, not just web frameworks, but also OS, operating system level frameworks that can work with user interfaces and just connect to a URL, send requests, send GET post requests, and get the return values and use those return values. So we'll start next with JSLim, show you how to use the IDE. It's got nice autocomplete, and we'll move on from there. So you have a full stack system that runs entirely in this little tiny toolkit.